Alright, yesterday in 8.4 we were simplifying. We were finding out the different parts of it, and then we were doing some multiplying and division. The biggest thing we were doing yesterday in 8.4, we were canceling out the rational expressions. And remember, rational is just a fancy word for fraction. And this part we're going to be doing addition and subtraction. Alright, now, go back in time to like 6th grade. If you're going to add and subtract fractions, what is the big key thing you have to add and subtract fractions? Common denominators. There we go. Alright, so for that one, there's your big asterisk. That's your big thing of the day for this part. Alright, so that's the big thing for today. For all the stuff that we're doing, we're going to have common denominators. Alright, I think I saw a couple people, Isaiah. Saw Isaiah the most when there was common denominators comment. So. Alright, so let's back up to, about Starburst. So I've got Starburst to toss back to you for answering questions in class. Let's back up to 6th grade here. Before we do one with rational expressions, let's just do just a basic fraction like this that you had to do. Because if we walk through the steps on this one, when we add and subtract the rational expressions, it's the same steps, it's just everything's more complicated. Okay, so for these, first thing we've got to do, we've got to find out what the least common denominator is. And there was a couple of different ways you could do this one. Most people probably started counting by 8. You count 8, 16, 24, 32, 40, that kind of thing. Then you would do the same thing with a 12. Until you found the first number they had in common, and there was your least common denominator. Okay, now what we're going to do is this one. We're going to show you the other way that you could have done it. The other way that you could have done it was you could take 8 and break it down in prime numbers. That 8 would be 2 times 2 times 2. 12 would be 2 times 2 times 3. If you went back and did the old factor trees with 8, made it 2 times 4, made it 2 times 2. Do the same thing with 12 and you could break it down. And here's technically what you could do to get the least common denominator if you had numbers that you weren't sure what the least common denominator would be. Go back and circle the parts they have in common. They both have a pair of 2s, so tell me what the common part is. So they both had a 2 here, they both had a 2 here. And then anything that's left over at the end of it, write that part down. You got a 2 and a 3. And if you multiply all those numbers together, 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. So that's another way you could get the least common denominator doing it that way. That you figure out what they have in common, and you figure out what they have left over, and multiply all that together to get your least common denominator. So, and there's probably other different ways you could get the least common denominator, but those were probably the biggest two options that you had probably seen when you're going through those. More people probably did this than, did anybody do this at all? Maybe? A couple of people did, yeah. Most people probably did it this way because it was a little bit easier because you just had to do the multiples of it. But, the way we're going to do it today is we're going to do it this way, where you figure out what they have in common, take out what they have in common, and whatever's left over, you just multiply all those pieces together to get your least common denominator. Alright, but either way we go. We had our common denominator was 24. And we're going to kind of do it a little different here. Alright, so to go from 8 to 24, what do you have to multiply by? Multiply by 3, right? And whatever you do on the bottom, you got to do the same thing on the top. So the top part we have to multiply by 3. From 12 to 24, multiply by 2. So 5 times 2 on the top. So for that one, we're going to get 9 over 24 and 10 over 24. Okay, now, and again, most people probably didn't do this step. They just went straight from here to here that they would think, kind of through in the head. But technically, that's what we're doing. We did 8 times 3 to get 24 on the bottom. We do 3 times 3 to get 9 on the top. And then one more step here that you probably didn't do, but we're going to kind of do it for this part is, once you've got your common denominators, you actually just put the two numbers together that you have on top and do what it says to do, either add or subtract. 9 plus 10 is 19. Okay, so if we travel back in time to 6th grade, that's what we had to do to find the least common denominator of just two basic fractions, two simple fractions. What we're going to do today is we're going to do the same thing, but now instead of it just being numbers, we're going to have x plus 2s and x minus 1s and x plus 3s and just all the different things we're going to do with x's and the different expressions that we can do from that. Okay, before we do any examples, let's give you all the steps that you may do. Okay, so the steps we need for adding or subtracting expressions. And this is the part where it's going to be similar to what we did yesterday. The very first thing we're going to do today is kind of going back to what we were doing yesterday in 8.4, is that you're going to factor everything as much as you possibly can. Okay, and that's the key thing is you want to factor everything as much as you possibly can. Numerators, denominators, it doesn't matter what it is. Anything that you see that you can do some kind of factoring to, go back through and do some kind of factoring to it. Okay, once you've factored everything out, then we're going to do kind of like we did back up here. You've got to determine what the denominators have in common. So again, kind of like we did up here. We'll figure out what they have in common, and then to find the least common denominator, you're going to combine what is in common with what is left over. And again, for this part of it, for this part that we're looking at right now, we're only looking in the denominators. The numerators, we'll worry about that in the next part, but for the first couple of steps, the key thing is you're really looking at the denominators here. Okay, so the first three steps, first step is you factor everything. Numerator, denominator, doesn't matter what it is, you factor everything out as much as you possibly can. And then steps 2 and 3, this is where you're going to find your least common denominator. Alright, once you've got the least common denominator, the denominators you're good with. You don't do anything else with the denominator part. So everything from here on out, we're working at just the numerator. So step 4, this is where we're back in the numerator now. That whatever we did to change the denominators, you've got to do the same thing with the numerators. So we're going to rewrite each fraction with the LCD. So step 4 is kind of a cleanup step. We've got our LCD kind of in the denominator now. And then step 5, I think we'll put that on the next page. we're going to go back and start changing the numerators. So you're going to have to multiply the numerators by the same thing you multiply the denominator by. Again, an earlier problem, that's where when we figured out that we went from back up here at the top, that's kind of this step here, that when we took the top part here and we multiplied to go from 12 to 24, we multiplied the bottom by 2. Now we're doing the same thing on the top. We're going to multiply the top by 2. You know, in this fraction, we multiplied the bottom by 3, so we had to multiply the top by 3. So that's kind of what step 5 is. Now again, the biggest difference is it's not just numbers now, it's expressions. It's x pluses and it's x minus, different things. Alright, and step 6, it takes all this work till finally, almost the next to last step is where you actually add or subtract things. So now you actually add or subtract the numerators. So we had to get to step 6 before we actually did any adding and subtracting. Where again, that's where we would take the 9 plus 10 and make it up to be 19. Okay, and the last thing that you'll do, and pretty much the last thing in all the parts that we're doing here in Chapter 8, is you're going to factor and simplify if it's possible. And it's about 50-50. Probably about half the time you'll be able to do some kind of factoring and canceling, and then the other half of the time you'll just have an answer, and that'll be your answer that you're looking for. Okay, so that's kind of the long part for today. Now what we're going to do is, the very first thing we're going to do before we do any addition and subtraction is, first couple of problems, just to make sure we're okay, we're just going to find the least common denominator. So for these, I'm going to give you two expressions that would be the denominators, you know, if we had it set up that way, and you're going to go back and tell me, all right, if these were your two denominators, what would the least common denominator be? Okay, so for example 1, we're going to do 2x plus 4. That's our basically one denominator. And then x squared minus x minus 6, that'd be another denominator. Okay, and again, the very first thing we've got to do is back up here. We're going to take everything and we're going to factor everything as much as you possibly can. So, same thing here, we're going to factor. Alright, well 2x plus 4. Not a whole lot to factor, right? Because if it's 2x plus 4, there's no x squared term we're looking at, so we're not going to have the two sets of parentheses. So if it's only two terms, what do they have in common? Both got 2, right? Yeah. So let's just take and divide them both by 2. So factor out the 2, take out the greatest common factor of 2, that's going to leave you with 2 and then x plus 2. Okay, for x squared minus x minus 6, for that part when we factor it, well now we're looking for the factors of negative 6, where the sum would equal negative 1. 1 and 6, not going to work, because that's either going to, if you're, you know, depending on if you add or subtract, if you add you get 7, if you subtract you're going to get 5. So it's got to be 2 and 3. And since this sign is negative, the negative's got to go with a bigger number. And then a negative divided by negative makes that a positive. So that's an x plus 2 and an x minus 3. Alright, so here's what we're going to do. So with those two fractions, with those two denominators, and again, we're basically pretending that that's our two denominators here. So this is something over, x plus 4, and this is something over this part. Doesn't matter what we have up here. If we have this part of it up here, what do those two things have in common? Got the x plus 2's, right? So take the x plus 2's out. And you don't have to scratch it all the way out, just kind of lightly cover it up. That the common part that you have here is x plus 2. And then if you take out that, tell me everything that's left over. You've got a 2 here and an x minus 3 here. And all that stuff together would be your least common denominator. And most of the time we don't put the 2 in the middle like that. So for our least common denominator, let's just put the 2 out front. So we got the 2 out front. We need an x minus 3, and we need an x plus 2. Okay, so that's what we're looking at when we're finding the least common denominator. Factor out your denominators as much as you possibly can. And tell me what they have in common. Now, if they don't have anything in common, then everything is left over, then everything would wind up being your least common denominator. But for all the problems we're doing, I think there should be at least one thing in common somewhere in there, some way at a point in time. So there should be something common that's in there. If you don't find anything that's in common, you may not have done the factoring right. So just be aware of that part. All right, let's give you one more of those, and then we'll do a couple of them where we just turn you loose here. So we'll do x squared plus 3x minus 4, and let's go with x squared plus 2x minus 8. Okay, so factor-wise, now, the numbers should be pretty small. You're not going to have numbers like 40 and 80 and 60 that you're going to have factored. The numbers should be pretty small. So if the factors are 4, it's either going to be 1 and 4 or 2 and 2. So what's the only way you can get 3? You can use 1 and 4 or 2 and 2. It's got to be 1 and 4, right? Because it's either 1 plus 4 or it's 1 minus 4, at some point in time there. The plus sign is here, so that sign always goes with the bigger factor. If you do a negative 4 divided by a positive 4, that means it's got to be a minus 1 there. And for this one, if it's negative 8, it's either 1 and 8 or 2 and 4. And the only way you can get 2, it's got to be 2 and 4. And again, the plus sign on the b term is there, so we'll need a plus on the bigger number. And negative 8 divided by positive 4 makes that a negative 2. And then you're just looking at it. So what do they both have? Both have an x plus 4. So take that part out of both of those. Just kind of lightly scratch it out. It doesn't have to be real dark, just enough you can kind of tell it's gone. And then from there, tell me what's left over. We got an x minus 1 or x minus 1 here, and an x minus 2 there. And all that thing, that is your least common denominator. So for that one, you've got x plus 4, x minus 1, and x minus 2. That would be your least common denominator. Okay, so the biggest part of finding the least common denominator is, I hate to say it's factoring, but it's really factoring. You have to take whatever the denominators are, factor them out as much as you can, and then from there you just tell me, all right, what do they have in common? Just look and see what they both have the same, pull that part down, and then just cover that common part up, and then whatever's left over, you have to bring that part down and put it behind what you had in common. All right, so let's do this. Before we give you one with different denominators, let's back up for just a second and make sure that you remember how to do stuff with common denominators. I think that's kind of important to get that before we go for this one. So for these, we're just going to ask you to add or subtract. So we'll go with d minus 3 over 2d minus 1, and then 3d plus 1 over 2d minus 1. So for this one, again, least common denominator is already there. We're all good for this part, so we don't have to worry about finding any denominators because these two things are the same, so we don't have to do anything. So if that's the case, I would say make this one big fraction. That's 2d minus 1. And then take these two parts and put together. So now you have d minus 3, and you've got to add that to 3d plus 1. All right, and for right now, don't even worry about the denominator. If you want, when you're doing this part, once you got it to here, I would say don't even worry about rewriting the 2d minus 1. If you want to, just put LCD, because once you've got the two fractions put together, and you've got the addition or subtraction part there, you don't worry about the denominator at all. It's done. When we get to the end of it, we'll pull it back in. So just be careful. So now you've got 1d plus 3d. That is 4d. You got a negative 3 plus 1, so that's a negative 2. Okay, so now we've added and subtracted. We've done everything we can do on the top. And the only last thing to do is, can you factor that one just a little bit? Just a little bit, right? You got 4d minus 2, you can take out a 2, right? So take the 2 out, that'll make it 2d minus 1. And once you factored the top, you've done all the work you can do. You've added, subtracted, you've combined like terms, you've put all the stuff together. You look at this thing and go, all right, well now I've got it here, I can factor here. Then you pull back in this least common denominator that you had of 2d minus 1. And we've got good news, right? You could, great news. You could save a bunch of money by switching your car insurance to Geico. No, you can cancel the 2d minus 1s, right? I'll try. So cancel the 2d minus 1s. Remember, you've got to put 1 back in there as a placeholder. Because sometimes if y'all don't do that, you missed a little bit of something there with the fractions. So on the top part, you have 2 times 1, which is 2, over 1, but that's just a 2. Okay, so for this one, we have definitely different denominators. So we're going to have to find a least common denominator off this part. And we're going to factor. Now, the good news is on this one is, if it's x plus 1, there's nothing you can do to factor that. It's x minus 1, there's nothing you can do to factor that one. So for the denominator here, it's just x minus 1. Because there's nothing you can do to factor that one. This one, though, we do have a little bit of something we can do here. It's only 2 terms. So they're not perfect. Well, this one's a perfect square, but that one's not. So if there's not perfect square numbers and it's 2 terms, the only thing left to do is find the least common denominator. Or find the greatest common factor, right? They both have an x, so take the x out. X squared, if you take 1 out, you've got 1 left over. If you take the x out, remember to put a 1 there for a placeholder, because you did take that x out, so that would be x minus 1. All right, and for least common denominator, tell me what they both have. They both have an x minus 1. So we'll take that out. And then once you take out the x minus 1, what's left over? Just the x. So your least common denominator would be x times x minus 1. All right, so from there, rewrite both of the denominators with x times x minus 1. And here's what you have to kind of think about when you do these. I'm going to write the original part of the problem in blue to know that part was already there. And then we're going to, when we change these things, when we go from here to here, whatever we did to multiply it on the bottom, I'm going to multiply the same thing on the top, but I'm going to do it in red just so it kind of stands out. So in this denominator, we had x minus 1 that we've got here. We put an extra x on the bottom. So for this one, you've got to multiply by x on the top. So now just be careful with that one, that when you multiply by x, let's just put them both in parentheses just to be on the safe side. Same thing with this one. We went from x squared minus x, which really this was x times x minus 1, right? So for this one, to go from here to here, it didn't change. So if the bottom doesn't change, then the top doesn't change. So this one, we didn't have to change that second fraction at all. Okay, so first one we multiplied by x on the bottom, so we multiply by x on the top. The second one, we didn't do anything to the bottom, so we don't do anything to the top, so it just stays the same. So here's where we're going to combine those two together. Now here's why I would say to kind of save a little bit of time. Instead of writing out x times x minus 1, since we're done with the least common denominator, I would just put LCD there. Because you're done with the denominator. Everything now is in the numerator, so now you're going to do x times, and we're going to put the x in front. X times x plus 1 plus a negative 2. So when you do that, you've got x times x for x squared, x times 1 for a 1x, and if you do a plus negative 2, that's just the same thing as a minus 2. And again, don't write down anything and just put LCD because we're not worried about the bottom part just yet. We're still cleaning up the top part. Alright, and once we got the top part, we've added and subtracted, we've done everything we can do. We're going to look and see if we can factor that at all. So are there any factors of 2 that could get us to 1? We could do 2 minus 1, right? So if we factor this one off, we put a 2 and 1 in here. Since the b term is positive, we'll put a positive with the 2. If you do a negative 2 divided by positive 2, that means the 1 is going to have to be a minus 1. Okay, and now we've done everything we can do to the top. We combined all the like terms. We've got it to here. We checked to see if we could factor it off a little bit. We've got it here. So now we can actually pull in that least common denominator. That was x times x minus 1. So now you pull it back in, and now you see if there's anything you can cancel. Oh, absolutely. Get rid of the x minus 1s, right? So that'll leave you with an x plus 2 over x. Okay, and I think the biggest thing I've seen that people struggle with in the past is they'll get the least common denominator and they get to here. And sometimes if they write out what the least common denominator is, they start to cancel things. So for this one, I would say once you find these two terms and you've got it rewritten, just use the letters LCD. Don't actually put what it is. Just put LCD and then realize you've got to go back and work everything else out in the top. And then once you've done everything in the top you can possibly do, then you pull back in the denominator and then see if there's anything that'll cancel. So hopefully that'll help a little bit because that seems like in the past that was where people always made mistakes. So hopefully that'll help us out just a little bit. All right, let's do 2 more examples. After these next 2 that we have, we'll stop and wait to pick up the rest of section 5, because to me the rest of section 5 really goes better with section 6, so we'll get that tomorrow when we come in and do that part. All right, everybody get on that one? Anybody still copying that part down? All right, 2 more examples. Oh, sorry. Let's go with x over x squared minus 4, and then minus 1 over x minus 2. Got to take each fraction and factor as much as you can. Now the good news is the top part up here, the x doesn't factor, the 1 doesn't factor, and even on this one the x minus 2 doesn't factor. So that denominator is still just x minus 2. Alright, this one, a little bit different, right? With x squared minus 4. It's only 2 terms, but they're both perfect squares. Anybody remember how to do that one? Once we get the answer, I think we do. Because it's just x squared and 4. Remember 4, you can make it 2 times 2. So that's where you can make 1 a positive 2 and make 1 a negative 2. So if you get the difference of 2 perfect squares, just break it up as 1's a plus and 1's a minus. Now if this had been 49, that would have been a positive 7 and a negative 7. If that had been 81, you'd have had a plus 9 and a minus 9. Okay, so now tell me what they both have. There you go. They both got an x minus 2, so take that part out. And then tell me what's left over. Well, just that x plus 2 here. So those 2 things would be your least common denominator. So x plus 2, x minus 2 is your least common denominator. Okay, so here's where we're going to take and rewrite those 2 fractions with that least common denominator. And if you want to go back and put the 1 here and put the x here, because that was the original part that we had, then we're going to figure out what we did to change it, and then that's the part we'll multiply in on the top as well. Okay, this one, it was x squared minus 4 on the bottom, which we said was really x plus 2, x minus 2. That's the exact same thing here, so this one didn't change, so if it doesn't change on the bottom, we don't change the top, so it just stays there. Alright, this one, we went from x minus 2, we multiplied by x plus 2 on the bottom, and since we multiplied by x plus 2 on the bottom, we've got to multiply by x plus 2 on the top. And once you've rewritten the tops and the bottoms, don't put the just put LCD on the bottom, because once we're here, you're done with the bottom until the very last step. So once you've got it here, don't worry about anything else. Now you're just going to take the top part and combine it all together and see what you get there. And I think that's the one thing you have to kind of get in your head, is that once you find out what the least common denominator is and you rewrite those 2 fractions, you're done with the denominator. Everything else is all in the numerator. So for this one, here's where you got to be a little bit careful. You've got negative 1 times x, and you've also got negative 1 times 2. So that's x minus 1x minus 2 on the top. Because you're basically just doing distributive property with the negative 1 there. So for that one, what is 1x minus 1x? 1 minus 1 is 0. If you have a 0x, then that's just 0. If you have 0 minus 2, that's just a negative 2. Okay, so now you've done 0 minus 2. There's nothing more you can do with that, and then you can go back and put in your least common denominator. You've gotten this thing down to negative 2. There is no x plus or x minus up here, so for that one, that would be your final answer right there. There is nothing you can simplify or cancel out there. Okay, for the last problem, still going to do basically the same thing, but we're going to change it up just a little bit. We're going to state the excluded values, where we're going to go back and do what we did yesterday. And then after that, we're going to simplify, and with the simplify, that's where they want you to add or subtract. So, and again, in the homework, sometimes they say restrictions instead of excluded values. So they may ask you to state the excluded values, and again, that's just the same thing as restrictions. Kind of going back and forth there. And then simplify. Okay, so for the last problem of the day, we're going to do 3x over x squared minus x minus 2. Minus 5x over x squared minus 3x plus 2. And for this one, a little different than the other problems we were doing, because before we do the adding and subtracting, the very first thing it says is to state the excluded values. And for that part, if you weren't here yesterday, that means you just take your denominators and set those equal to 0. But the good news is, when you do that, you've basically done the work you need to be able to simplify, to add and subtract, because to get these excluded values, you're going to have to factor anyway. And the last number is 2. There's only one way you can get 2. It's got to be 2 times 1. So it's just a matter of getting the right signs in the right place. Since the b term is negative, the bigger number has to be negative. The other number would have to be a positive. And for this one, same number, just different signs. So it has to be 1 and 2. In that case, the b term is negative, so the bigger number has to be negative. And if you do a positive divided by negative, that means the other number is going to have to be a negative. And to find the excluded values, just take each of the denominators you have there, set each piece of it equal to 0, which, again, for these, you're just going to change the sign. Same thing here. Set each of those equal to 0. And there's all your excluded values. Now, and it doesn't matter, because people may say, well, does it matter that the 2 showed up twice? Not really. I think in the homework you would just have to list it one time. So if it shows up twice, that's okay. It repeated itself a couple of times, and that's fine. So from there, first part's done. We've got the excluded values now. We're going to leave off 2, negative 1, and 1. You don't have to say the 2 twice because we've already named it here. So our excluded values are basically 2, negative 1, and 1. And then the next thing is to simplify. That's where we're going to do the addition and subtraction. So we've got to find the least common denominator. The good news is, for the least common denominator, is we've already got it factored here. So go back and tell me what they have in common. Common part's the x minus 2's. And once you take out the x minus 2's, the parts you have left over, that's the x plus 1, and that's the x minus 1. So when you bring in the excluded value, the restrictions like we did yesterday, you're really not adding any work to it because you're going ahead and factoring it. You're getting the excluded values, but at the same time, you've got it factored, so you've got everything you need here. to go ahead and tell me what the least common denominator is. So that's why you can do two things here and not really do any extra work, because you've done the work you needed to get the exclusions to do the same work you need to get the common denominator. So it's all tied together when we're going through this thing. Okay, so take both of the fractions and rewrite them both as x minus 2, x plus 1, and x minus 1. X minus 2, x plus 1, and x minus 1. This originally was a 3x, that was a minus, and that was a 5x. Okay, and we don't have to go back to the original problem once we've kind of pulled this part down, because basically we're going from this denominator to here. So we had the x minus 2. We've got the x plus 1. The part we added in extra was the x minus 1. So since there's the x minus 1 we put on the bottom from here, we've got to put an extra x minus 1 on the top. For this one we had x minus 1 and x minus 2. So we put in an extra x plus 1 on the bottom. And whatever you have on the bottom, you got to put that on the top. Okay. And again, here's the biggest part. Usually this is where people would get stuck in the past on these. So when you do this part, and you've got these two things written out, don't write down what the least common denominator is, just put LCD. Because once you've got it rewritten, you don't do anything to the bottom. The bottom's done. Now everything is in the top. So now you actually have to do the top part here. You have to do 3x times x minus 1 minus 5x times x plus 1. That once you've got the least common denominator written out 2 times, you don't use that denominator again. It's done. Everything now is in the top part that you got to work on. Now you do have to do a little distributive property. You've got 3x times x, that would be 3x squared. 3x times a negative 1, that's a negative 3x. And be careful, because that is a negative 5x, so technically that negative 5 is what you're going to do distribute with. Negative 5x times x is a negative 5x squared. And negative 5x times 1, that's a negative 5x. Again, and it also saves time. If you just write LCD, it's going to save you some time because you don't have to write all three of those parentheses. And now you're just combining like terms. You've got 3x squared minus 5x squared. That's negative 2x squared. Negative 3x minus 5x, that's a negative 8x. Now we've added, subtracted, we've multiplied, we've done all the work we can do on the top, we've got it to here. And once you get it to here, is there anything we can do to take some factoring out of this thing? Yep, they both have a 2, they both have an x, they both have negatives. So let's take out a negative, a 2, and an x here. We take out a negative 2x. Negative 2 divided by negative 2, that's a 1. And we're going to take out one of the x's, that's 1x, or we can just put x there. Negative 8 divided by negative 2, that's a positive 4. If you take the x out, it's just going to be the 4 that's left over. Okay, so we've added, subtracted, we've done everything we can do. We've got here, we factored it out just a little bit. And now that you've got the top done, then you can bring back in your least common denominator. So now you've got the x minus 2, the x plus 1, and the x minus 1. And there is nothing that cancels, so for that one, that would be your final answer.